Hello and welcome to another video. In this video, we shall see about optimization. Optimization is present in all walks of life. Optimization is the process of finding the best solution from a set of feasible solutions. It is used in many fields like engineering, business, machine learning, economics, etc. The goal of an optimization is to maximize or minimize an objective function while satisfying constraints. These are few real-world examples of optimization. Supply chain and logistics optimization. Companies like Amazon and FedEx use route optimization algorithms to minimize the delivery time and fuel cost. Similarly, in manufacturing, process optimization can be done. An example is Tesla's gigafactories. Optimize production layouts and energy use to improve battery manufacturing efficiency. Optimization is present in finance as well. Say, for example, in mutual funds, according to the person's appetite to take risk, we optimize the share of debit funds, hybrid funds, equity funds, etc., so that the person gets maximum profit according to his risk profile. Traffic and transportation optimization. Google Maps use real-time data and algorithms to find the fastest routes and reduce traffic congestion. Energy consumption optimization. In smart grids, the energy companies optimize the power distribution to reduce waste and prevent blackouts. Healthcare and hospital optimization. Operation room scheduling. Hospitals optimize surgery schedules to maximize patient throughput and minimize the wait time of patients. Sports performance optimization. If you have observed the Formula One race, the teams optimize the pit stop strategies, aerodynamics of the vehicle, fuel efficiency for maximum performance. E-commerce and digital marketing optimization. Companies like Amazon, Netflix use optimize content recommendations using artificial intelligence to increase the user engagement. Now we will see the components of a optimization problem. There are mainly three components for an optimization problem. The first one is decision variables, the values that we adjust to find the best solution. The next component is objective function, the function we aim to optimize. We will have some parameter, we will have some function which we need to optimize. That is the objective function. And these objective functions are optimized as subjected to some constraints. The constraints are limitations or restrictions on the decision variables. So we are trying to find a suitable optimal decision variable values which will maximize or minimize the objective function subjected to the constraints within the constraint limits. So the mathematical representation will be something like this. We will find the minimum or maximum of the objective function f of z, where z is the decision variables subject to the constraints. The decision variable c belongs to some subset of all the values that the z can take. So optimization can be of different types. We classify them as linear and nonlinear optimization, continuous or discrete optimization, constrained, unconstrained optimization, deterministic, stochastic optimization. Linear and nonlinear, based on what model we use, what objective functions we use, we can classify the system into linear, classify the optimization problem into linear as well as nonlinear optimization problem. To begin with, now we will discuss with linear optimization problems and continuous and discrete optimization problems. If the decision variable is a continuous value, suppose we have to optimize the speed of a vehicle, the delivery reaches a specified time, then the speed is a continuous variable. A discrete optimization, an example of a discrete optimization is if suppose you have to allocate some task to so and so person, many persons. The number of persons is a discrete value. So that there the decision variable is a discrete value. Similarly, constrained and unconstrained optimization. If there is no constraints and z can belong to the whole set, whole real plane, then it is an unconstrained optimization. We are trying to minimize only the objective function. But mostly the optimization problems will have constraints included in it. There can be equality constraints, there can be inequality constraints as shown here. Deterministic versus stochastic optimization. If the decision variable is affected by some kind of uncertainty, it can be errors, measurement error, it can be some value added, noise added to that, noise added to the state variables. So those will require stochastic optimization techniques. Optimization techniques are solved, can be classified into different types, like analytical methods are used to solve the optimization. So if in analytical method, we can find mathematically the solution, we can derive mathematically a solution. But this is possible only for simple optimization problems, the linear optimization problems. For more complicated nonlinear optimization problems, we use numerical methods, gradient descent, Newton methods, and even larger systems, we use heuristic methods, meta-heuristic methods like genetic algorithm. We will see gradient descent method, which is a key optimization algorithm to understand how we are solving an optimization problem. Here, to find the solution of an optimization problem, we iteratively update the variables in the direction of steepest descent. So as in the algorithm shown, we repeatedly update the control decision variables. Set k plus 1 is updated from set k by using the information of the function, derivative of the function at that previous point of decision variable, set k. So this will help us to understand the steepest descent method, the direction in which the cost is decreasing, the function value is decreasing. So we will update the control variable such that the cost is decreasing if it is a minimization problem. So here it is a graphical representation where P is the set of all possible values of Z, and we try to substitute K1, K2, K3. We try to update the values in each iteration, update the values of Z in each iteration, and we will stop at some point where we have the minimum value of C. Now, what are the challenges in optimization? We will have a local and global optima. Sometimes for a nonlinear optimization problem, if it is a non-convex optimization problem, we may stuck in the local optima. But in convex optimization problem or linear optimization problem, whatever the solution that we obtain, the local and the global will be one and the same. But the problem arises when in a nonlinear optimization problem, we may end up at a point where it is only a local optimization, local optima. Computation complexity. Larger problems requires more efficient algorithms. So if you are able to find an analytical solution, then it is much easier. But for numerical methods or meta-heuristic methods, you need large computation power. There can be multi-objective optimization problem where we have to balance conflicting objectives. Optimization problems, as we have seen earlier, it is widely used in many domains. Optimization is a powerful tool across all various domains. Different techniques exist based on the problem type and constraints. Modern advancements uses artificial intelligence learning for more efficient optimization. With this basics, we will see more about optimization in the next videos. Thank you.